Welcome to Physics पाठशाला. गुड मॉर्निंग टू ऑल. अभी तक हम लोग पढ़े हैं हाउ हीट ट्रांसफर्स थ्रू सॉलिड एंड लिक्विड. नेक्स्ट इज व्हेन देयर इज नो मीडिया, हीट transfers from one place to another through radiation. So radiation, the radiant energy transfers, and that does not require any media. It transfers as an electromagnetic wave. This radiation travels as an electromagnetic wave. As per principle of calorimetry, or law of mixture, when two objects, one at higher temperature and another at lower temperature, brought in contact, दोनों दूसरे को टच में जब आएंगे, एक का टेम्परेचर हायर है, दूसरे का टेम्परेचर लो है. When there is a difference in temperature between two bodies and both bodies brought in contact with each other, then some amount of heat energy will transfer from body A to body cold body, from hot body to cold body. Means जिनके पास higher temperature है, from that body to lower temperature object को some amount of heat will transfer when both will come in contact. इसका मतलब कि जितना हीट देगा उतना वो रिसीव करेगा. That means the amount of heat will be lost by hot body will be amount of heat energy that will be lost by hot body will be the amount of heat energy that will be gained by cold body. So this says principle of calorimetry or law of mixture. This is our law of mixture. Law of mixture says जब दो ऑब्जेक्ट हैं, दोनों ऑब्जेक्ट अलग अलग टेम्परेचर में है, एक हायर टेम्परेचर है, एक लोअर टेम्परेचर है, और दोनों जब साथ साथ लाएंगे, दोनों टच करेंगे, कुछ हीट एनर्जी हायर ऑब्जेक्ट से हायर टेम्परेचर ऑब्जेक्ट एंड हॉट बॉडी से कोल्ड बॉडी को ट्रांसफर होगा. एंड दिस अमाउंट ऑफ हीट दैट विल बी lost by hot body will be equal to the amount of heat energy gained by this cold body. Next is previous theorem says suppose कोई एक ऑब्जेक्ट है, उसके we do not know कुछ तो टेम्परेचर होगा ही, और इधर सराउंडिंग है, तो हमेशा it will keep on emitting some energy and keep on receiving some energy from surrounding. It will keep on emitting and keep on. This is called pre-first theorem. Pre-first theorem says all bodies start or all bodies do emit heat energy or radiant energy at all temperatures. At the same time, it keeps on absorbing heat energy from its surrounding. That means reverse theorem says objects will keep on emitting radiant energy with its surrounding और surrounding से जो emit रहा होगा उसको वो ऑब्जर्व करेगा. That means emit करेगा और ऑब्जर्व भी करेगा. It keeps on doing at all temperature, and this happens till equilibrium. Once equilibrium point is attained, once equilibrium is attained, in that case, total, that is exchange between them, remain, that is exchange of radiant energy, that is amount of radiation or radiant energy emitted by the body is equal to amount of radiation absorbed. Amount of radiation emitted is equal to amount of radiation absorbed by this body. Hence, it remains at equilibrium with surrounding. There is no, that means surrounding temperature and body temperature becomes equal. In that equilibrium, thermal equilibrium state, there is no need absorb of any heat. Its amount of heat emitted by the body is amount of heat absorbed by the body for a particular duration. Using these two theorems, we find that we'll prove Kirchhoff's law. Kirchhoff's law says for a particular corresponding to a particular wavelength of any radiation, because as you know, radiation is electromagnetic wave and it moves with at different frequencies. It moves at different frequencies or at a different wavelength. For particular wavelength or corresponding to a particular wavelength, Kirchhoff's law says emissive power to the absorptive power. Emissive power to absorptive power of all objects is equal to constant, and that is equal to emissive power of the black body. Can note down. Kirchhoff's law says at a given temperature corresponding to a particular wavelength, emissive power to absorptive power of all bodies are equal, and that is emissive power of black body. Now, let us say we have two bodies of object 1, we have object 2, and we have another object, that is black body. If all three are of similar dimension, that means the exposed area is same for all. In that case, the amount of heat that is absorbed, though depend on bodies, but the amount of heat will incident will be same for all bodies, because here the exposed area is same for all. That means the energy that will come from surrounding, the amount of incident heat energy will be same for all three objects. Suppose these three objects are kept inside certain closed surrounding. and suppose T0 is the temperature of the surrounding and उसके अंदर तीनों ऑब्जेक्ट है, ऑब्जेक्ट 1, ऑब्जेक्ट 2 और ब्लैक बॉडी, तीनों का रख दिया गया है और तीनों का डायमेंशन जो है सेम, डायमेंशन इज सेम मींस जो एक्सपोज एरिया है तीनों का बराबर है, तीनों का बराबर है. सपोज इट इज A1 इक्वल टू A2 इक्वल टू A ऑफ ब्लैक बॉडी. तो जब एक्सपोज एरिया बराबर है तो इंसिडेंट एनर्जी जो है दोनों के लिए बराबर होगा, तीनों के लिए. Q1 इक्वल टू QI1, Q इंसिडेंट 2 इक्वल टू Q इंसिडेंट ब्लैक बॉडी. Once after a certain time gap, कुछ टाइम के बाद कर तो ये सराउंडिंग का टेम्परेचर के साथ इक्विलिब्रियम में आ जाएगा. Now, after thermal equilibrium is attained, the net absorb and emit of energy combined is zero. जितना इसका मतलब जितना एनर्जी ऑब्जर्व करेगा उतना एनर्जी एमिट करेगा. ऑब्जेक्ट 2 भी जितना एनर्जी ऑब्जर्व करेगा उतना एनर्जी एमिट करेगा. ब्लैक बॉडी भी जितना एनर्जी ऑब्जर्व करेगा उतना एनर्जी एमिट करेगा. ये तो हमेशा ऐसे करता है. ब्लैक बॉडी will emit the whole of the energy ऑब्जर्व. तो अभी तीनों जो ऑब्जेक्ट है, ऑब्जेक्ट 1 जितना ऑब्जर्व किया एमिट किया, ऑब्जेक्ट 2 भी जितना एमिट किया उतना ऑब्जर्व, जितना ऑब्जर्व किया था उतना एमिट किया, ब्लैक बॉडी भी जितना ऑब्जर्व किया था उतना एमिट किया. नाउ इन ऑल केसेस सपोज नाउ व्हाट इज ऑब्जेक्टिव पावर फॉर A1, what is objective power for object 1? Objective power for let is A1 or let objective power for object 2 is A2. This A1 is amount of heat absorbed by amount of quantity of heat incident. Similar manner, when for object 2, what is objective power? Objective power is amount of heat absorbed by object 2 to the amount of heat incident. And for black body, amount of heat absorbed is equal to amount of heat incident. Hence, it is always 1. It is always 1. That means objective power of black body is 1. Now, when we come to emit case, the heat amount will be emitted by object 1 is equal to E1AT. Suppose it is the area exposed and it is the time duration T. Then the amount of heat energy emitted QE1 is equal to E1AT, where E1 is the emissive power of object 1. Similarly, E2 is emissive power for object 2 and E is the emissive power of black body. Now, once thermal equilibrium has been attained, during that thermal equilibrium, this quantity of heat absorbed is equal to quantity of heat emitted. Now, using this, here we know what is QA1. QA1 will be A1 QI. QA1 is equal to QI. Suppose the amount of heat during equilibrium is QI1 is equal to QI2 is equal to QI. Black body, that is Q. Then QA1 becomes Q. E1 अभी आज the quantity of heat absorbed is equal to quantity of heat emitted for A object 1, QA1 is equal to QE1, QA2 is equal to QE2, QA black body is equal to QE black body. Now during this thermal equilibrium, as both QA1 is now A1, A1, Q1 is equal to E1 AT. For object 2, QA2 is A2 Q I is equal to E2 AT. For a black body, again it is black body, it is QABB is 1 into QI. Absorptive power of black body is 1 into QI is equal to QEEB. QEEB is EAT. Now, once the incident amount of incident energy is same for all, once the incident energy is same for all, we can say A1 by E1. Now A1 by E1 is equal to Q by AT. E2 by A2 is again QI by AT. You can say it is Q1 by AT in this case, Q1 by AT in this case, and 1 by or E by 1 is equal to Q1 by AT. Now in all cases we find Q1 by AT or it is Q by AT if Q1 is equal to Q2 is equal to Q QI1 is equal to QI2 is equal to QIBB. We can say in all cases it is Q. In all cases it is Q. Then it is Q by AT, that is E. Hence it is proved that E1 by A1 is equal to E2 by A2 is equal to E at that temperature corresponding to a particular wavelength. It shows for all objects the ratio of its emissive power to absorptive power is a constant, and it is equal to emissive power of the black body. Okay, black body. We find Newton's law of cooling, can discuss on it. It says once an object is kept in and the surrounding temperature is, suppose T0 is less than the temperature of the object. In this case, the object starts get cooling. Objects get cooling or it starts radiating heat energy. So this rate of cooling or change in temperature with time is proportional to the temperature difference, how much difference is there, and proportional to the exposed area. Correct? Now, once we equate, we will find dt by dt is equal to AK. A is the exposed area and some constant K times T minus T0, T minus T0, and this negative sign indicates rate of cooling will be maximum at initial stage and it will keep on decreasing as time with time, because as time will increase, temperature of body will decrease, and this difference will decrease. Hence, with decreasing temperature of the body, this rate of cooling will decrease.